All right, welcome back, Patriots. It's been a long time since the last time I made a video. Sorry, I had some technical difficulties with my tablet for a while, but we're getting started again. If you do not already know this, I am Mr. Love, aka the Math Patriot, bringing you more fun and exciting lessons from the world of high school math. We are once again live in front of a class. Say hi, class.
Hi, class.
There's always one. Okay. So, today we are talking about ratios, proportions, and similar polygons. This lesson is going to feel like it's got two very different sections, and it does. Ratios and proportions are first, and then we use proportions in similar polygons, so it's there. First thing we're going to talk about is what is a ratio. Do we remember that from our middle school classes?
Somewhat.
All right, what's a ratio look like?
1 to 3, colon 1, 3.
1 to 3. Could I rewrite that a different way?
Yes, 1 over 3.
By the way, the reason they have all these answers is because I started the lesson and did about 5 minutes of it and then realized I wasn't recording. So they've already heard all this. But, all right, so 1 to 3. Now, we could rewrite that also. 3 to 1, having an improper fraction is technically fine as well. One thing we don't want to do is something like this. While 6 to 4 technically is correct, I'm going to prefer to reduce those. Whoa, not 6. Reduce those by a factor of 3. Got 2, sorry. So to get 3 to 2 and also 3 over 2. Another thing, it is okay for us to have zeros. So saying, for example, 0 to 7 is fine. That converts to 0 over 7. The one thing we absolutely cannot do is 7 to 0 because that converts to 7 over 0, which is bad. Okay, so reduce our fractions where necessary. That's also why I've got the calculator here. For the most part, when we do reducing fractions, our calculator won't turn on. There it goes. Okay. For the most part, when we reduce fractions, we've been doing that for years. It's easy enough. Find greatest common divisor, greatest common factor, divide them out. That's easy enough. But in some cases, our numbers are very, very large, and it becomes a little bit of a hindrance to reduce fractions. I'm going to show you all the easy way. Since we have this fancy calculator on our desk, we might as well use it. So first off, let's take one we know. 6 divided by 4. Easiest way to reduce a fraction is to do math, which is right below alpha, so the math button. And then press option 1 is to fract, which means convert to a fraction. So just press enter on it, and then press enter to submit, and it will reduce the fraction for you. That's really beneficial whenever you have things like, for example, just a general number you want to convert to a reduced fraction, like 0.4872. 0.4872, math, enter. That is 609 divided by 1250. You're lost?
Yeah, I'm lost in how you get.
So you see right on the calculator, you see the blue button?
Yeah.
That says second. You see the green button that says alpha.
Yeah.
The one below that says math. That's the math button. Press math and then enter twice. And it will convert the last thing entered into a fraction, a reduced fraction. So for example, if you type in 0.5, we already know what that is. It's 1/2. Math, enter. And my calculator's lagging here because I'm doing too much on my tablet at once. Actually, let me go ahead and close some of that. Boom. Come on. I don't need PowerPoint. I also don't need my phone up right now. I don't need Windows Explorer open right now. Let's see if that helps. All right. So yeah, type in your fraction, math, enter. Let's do again 5 divided by 18. Math, enter. Reduces to 5/18. Make sense? What? 5/18. 5 over 18. Okay. So as far as what a ratio actually is, a ratio is just a comparison of two numerical values, two quantities. You write it as either a fraction or as a two numbers with a colon in the middle. Of the two, I prefer this one because it's actually easier to do math on it. Now, an extended ratio, you got 3 or more quantities. The way you write that is something like this. 2 to 4 to 5 to 8. Now, this is when you have essentially several quantities that are all related. In a high school, if we wanted to compare the numbers of students from each class, you could do something like this. The ratio is, 1,400, or no, that's way too many. The ratio is like 703 to 709 to 624 to 903 when you're talking about freshmen to sophomores to juniors to seniors. You could do that sort of thing when you have more than one. And we'll have an example of that, more than 2, as we go through. All right. So let's practice just writing a ratio. In 2007, Boston Red Sox, by the way, no idea if this is accurate or not. I just made some numbers up. Okay. Actually, somebody else gave them to me. Okay. In 2007, Boston Red Sox won 96 out of 162 games. Write a ratio from the number of games won to the number of games played. So this tells me I want to do 1, 2 total. There's my colon. So what's my number of games won? 96. 2 games played is 162. How do I write that as a fraction? 96 over 162. And this is where we want to reduce. And yeah, you can do that by hand if you want to. But 96 divided by 162. Oh, math, enter. Yes. So that is 16 to 27. Whoa. 16 to 27 or 16 over 27. Be careful because sometimes I'll give you situations where I give you games won, but I ask you for games lost. And I trust y'all can subtract that out to find games lost. What? Yeah. So if asking you to find games lost, it's just games played minus games won. Be careful though, because sometimes there's situations where there's more than 2 outcomes. In professional baseball, ties are not allowed. And so it has to be either won or lost. There are other sports where ties are okay. And so in that case, you couldn't just subtract it out. So just be careful about our categories. Yes? Yes, you could do that, the whole, like, where you do the alpha y equals thing. You can do that. But I just prefer not to because it's more complicated. Okay. Number 2, 182 girls in the sophomore class of 305 students. Ratios of girls to total students. Well, okay, so the question was total students or just the sophomore class. In this context, all we have is information on the sophomore class, so that's what we got to use as total students. So, ratio of girls to total students. Number of girls is 182 to 305, which is 182 over 305. And you can try to reduce that if you want to. It already is reduced. So, there we go. All right, next up, example 3. Here's our first extended ratio. Ratio of the measures of the angles is 2 to 3 to 4. Find the measures of the angles. Now, here's what this actually means, okay? For every 2 degrees of the first angle, there are 3 degrees of the second angle and 4 degrees of the third. However, what's the problem with that scenario? Yeah, I need 180 degrees, and I've only got, 9? Yes, okay, you're right. We're getting there, okay? So, essentially what has to happen is I have to start raising these by the same, or raising them in proportion or in ratio to each other. So, if I was to add another 2 degrees to this one, over an angle H, I would have to add 3 degrees. Sorry, that would make it 6 degrees. And add 4 degrees to K, which would give me 8 degrees, but that's still not enough. I got to find that sweet spot where I raise it high enough that they exactly equal 180 degrees. The easiest way of doing that is not by just guessing and checking, but by saying that that's 2x, 3x, and 4x. And then solve for x. So I've got 2x plus 3x plus 4x equals 180. Now, solving 2x, 3x, and 4x makes 9x equals 180. Therefore, x equals 20. Then, to find the measure of each angle, we're going to do 2 times 20, 3 times 20, and 4 times 20. That gives me 40 degrees, 60 degrees, and 80 degrees, which does add to 180, which is exactly what I wanted. Most common places in geometry class, at least, to use these extended ratios is for angles inside of a polygon, as well as for perimeters of polygons. It's in 2 common places to use it. Okay, honestly, I planned on doing this, but I changed my mind. I don't really like this extreme and mean thing. I'm not going to use it at all. Okay, first off, a proportion is a statement that 2 ratios or 2 fractions are equal to each other. Okay, so you got fraction equals fraction. Now, whenever you have a fraction equals fraction, you are allowed to cross multiply them. The butterfly method, the cross multiplication, the bat and ball, whatever somebody said, alligator method earlier, I don't know. I've never heard that before. Butterfly? Yeah, butterfly and cross multiply seem to be the most common ones, where you multiply B times C and A times D and put an equal mark in the middle. So A times D equals C times B. Now, here's the danger though. Please realize that that is a tool for a specific job. That specific job is solving proportions. You cannot use cross multiplication or butterfly method or whatever you want to call it. You cannot use it for multiplying fractions, for adding fractions, for dividing fractions, for anything in the world except for ratios equal each other, which is a proportion. Use it properly, don't use it anywhere else. Okay. Let's solve this guy. What do I got?
16 times 27.
Okay, yeah, I'm going to multiply them. I'm going to do the 9 first because I want my x's on the left. 9x equals 16 times, and my calculator is being weird, 16 times 27. You know what? With all that lag, I'm just going to let y'all do it. Okay, it was what? 432. Divide through, and I've got 48. Now, problems like this are where people will start using the phrase cross, multiply, and divide. Have any of y'all heard that before, cross, multiply, and divide? Okay. I'm going to let you know right now, I hate that phrase. It's misleading. I mean, if you understand this context, it makes perfect sense, but when you use it out of context, it causes problems. So here's why. Let's look at this. Now, first off, we didn't do it on the last one because you couldn't have, but in situations like this, reduce first if possible. Like, for example, this 33 over 11, will that guy reduce? Yes, to 3 over 1. Then cross multiply. So 3 times x plus 2 is 3 times x plus 2 equals 1 times x plus 22. Now, I wrote that out like that this time just to show you explicitly where it comes from. From now on, moving forward, I'm going to go ahead and do the next step all combined. Just go ahead and do the distribution as I go. So here I've got 3 times x, and 3 times 2 is 3x plus 6 equals x plus 22. Now let's solve. What am I going to do?
Subtract x.
Subtract x on both sides gives me 2x on the left.
And
Subtract 6 gives me 16 on the right. Therefore, x equals,
8.
Thank you, 8. I don't know why I wrote 2. X equals 8. Now, from this, can you see why I don't like the phrase cross multiply and divide? What one word could I change there to make it completely accurate?
Solve.
Solve. If I say cross multiply and solve, it works out great. On this particular problem, the solving step just happened to be division. Okay, so cross multiply and solve. All right, Mayor Hernandez is conducting a random survey of 200 voters and found that 135 approve of the job she is doing. If there are 48,000 voters in Mayor Hernandez's town, predict the total number of voters who approve the job she is doing. By the way, this whole idea of taking a survey of people to predict the outcome or predict the results from the full population is a very basic intro into statistics.
Yeah.
Okay, works out great if you properly randomize your sample. If you don't, it causes problems. Like for example, what if I just take all the phone numbers in the town? Well, let's not even phone numbers. Let's just take every single person and write them in alphabetical order, and I randomly pick from those people. Do you think that might be a good chance of being a fair representation of my entire town?
Not if there's a majority.
What? Not if what?
Not if there's a majority.
Okay, so not if there's a majority. But in theory, if there's a majority, then the people I'm randomly picking from, there would be more people from that majority in the random sample. In theory, not always. Let's contrast it to something else. What if I want to do a random sample? So Mayor Hernandez, let's just say that she's from the let's use ones that don't actually exist anymore. Let's say that she's a Whig. You covered Whigs in your history classes?
Yeah.
Whigs and Loyalists. Let's just say she's a Whig. Okay? She goes to the local Whig convention, and at the local Whig convention, she picks 200 random people from the Whig convention and surveys them. Will that be a fair survey?
No.
Why not? Because they're all in the same political party, right? But if she randomly samples from the entire town, she's got a better chance of it actually representing the entire town. Okay? So, sampling practices is actually a very huge topic in statistics. By the way, you have a chance to take statistics your senior year here at Eastview. So depending on where you want to go for calculus versus statistics, they both have their merits, both great classes. I've taught statistics, never taught calculus, but statistics is a great class. Anyway, here's what you've got essentially. You've got the survey, and you've got the entire town. In statistical language, that's called the sample. Also called, the full town is called the population. Those are not fractions, that's just divisions of a box. Okay? T-I-O-N. Let's spell properly. Okay. So what you're going to do is you're going to take, essentially, we've got people that approve and people that are voters or the entire sample. What we're going to do is make a fraction out of those that approve divided by the total. So with the sample, how many people approve? 135. In the sample, how many are there total? 200. In the town, how many people approve of her? We don't know. We're going to use an X there as our unknown. How many people are there total? 48,000. So, set those equal to each other, cross multiply, and solve. This is one place where you could reduce first. It's not going to help us much, but I'm not going to bother with it. 200 times x is 200x. 135 times 48,000. It's 6 million. Somebody help me out. 480,000. Then we're going to divide by 200. And let's see if I can do this in my head. Those two zeros are going to cancel out. Going by 100. Now I'm dividing by 2, so that's 32400. 32,400 people most likely approve of her in town. Did I get it right?
No,
Yes.
Let me see what you did. I think you typed something in wrong. Yeah, you multiplied by 200, not divided by 200. All right. All right, here's that section break. I'm sorry, what? 32,400. Okay, here's that section break where things start to feel a little bit different. Similar. Similar polygons are polygons that have the same shape, but not necessarily the same size. So, our symbol for similar figures is this, the tilde. Now, it made it through on y'all's sheet, not on mine. This box should have been a similar symbol. Okay, so similar, same shape, could be different size. Okay, well, let's jump over here and talk about symbology for a second. Same shape. What does this symbol equal or mean?
Equal.
Equal. Okay, concept though. What does equal mean? The same size, right? If I compose those two symbols together and say it is both the same shape and the same size, that's congruent. That's where the congruent symbol comes from. Okay? Now another symbol we're going to need here is proportional. Ugh, that looked bad. Okay, think of like an alpha symbol or an ichthus fish. They just got really, really wide. It's got a wide tail. That's for proportional. Okay, that's why I wrote right below proportional. Okay, so when two polygons are similar, only if they have congruent corresponding angles and their corresponding sides are proportional. And I'll show you what that proportional means in the next few examples. Okay, so whenever I use that symbol, it is proportional. All right. So list all pairs of angles and write a proportion that relates to the corresponding sides. So this guy, just like in congruency statements, is essentially a roadmap. It tells you that angle A is congruent to angle X because they are both in the first position. Angle B is congruent to angle Y, and angle C is congruent to angle Z. Also, looking at my sides there, AB, position 1 and 2, if I make a ratio of AB to AY, or to XY, notice they're not equal, but they are proportional. They form a ratio. That's going to equal BC over YZ, which is equal to AC over ZX. What I'm saying there is that AB and XY are not the same size, but if I divide them, I will get the exact same ratio as if I took BC and divided it by YZ, which is the exact same ratio as if I divided it by, or AC by ZX. Those guys are going to be used to come up with the scale factor. If I take one of them and reduce it, it's the scale factor, which I will abbreviate as SF. Okay, that'll make more sense as we go through. Okay, the purpose of that extended equation there is to say you can mix and match them. The first one equals the second, first equals third, or second equals third. You can mix and match those as you need to. Sir?
Proof?
Not today. No proofs today. Well, I mean, if you really want to, I can go mix them up. No? Okay. All right, now, so here's the idea about scale factor. We're talking about using the word to, so the scale factor of one triangle to another, as in the same way as using that verbal to. So like if I had 5 to 6, it's 5:6. There's another way of looking at this grammatically. I'm not going to get into that whole conception because I find that whenever I talk about it, it causes more problems. Just follow the direction that I do this and it'll make sense. Okay, so our diagram, ABC is similar to XYZ. Here I've got ABC to XYZ. So I'm going from ABC to XYZ. And so what that means is whenever I write my ratio, I've got 6 to 3, which becomes 6 to 3, which is 2 over 1, or 2. Does that make sense, the way that I'm writing that?
Yeah.
I could say it the other way around. I could say that I'm going from XYZ to ABC, go the other way around. In that case, I've got 3 to 6, which is 3 over 6 or 1 over 2. Just follow your directions there, okay? All right. Now, here's where the lesson gets a little bit tedious. Determine whether they are similar, and if so, write the similarity statement and the scale factor and explain your reasoning. So I need two things. Just like our back old school CPCTC, I got to show that corresponding angles are congruent and corresponding sides are proportional. Angles are easy. Angle W is congruent to angle P. Angle Z is congruent to angle S. Angle Y is congruent to angle R. And angle Q is congruent to angle X. I know that because of all of the markings inside the angles. Now for proportionality, I've got to do a little bit more work. Which side is going to correspond to the 9, to WZ? PS. I'm going to make a fraction out of those two. So I've got 9 over 6, and then reduce it. What does it reduce to?
1 over 3, 3 over 1.
They got a common factor of 3, so it's 3 over 2. All right, now I'm going to do it with 15, which is corresponding to 10. 15 over 10 is equal to, reduces to 3 over 2. Now, 18 and 12. 18 over 12 reduces to 3 over 2. And then 12 and 8 reduces to 3 over 2. Since they all reduce to the exact same fraction, that means they are all equivalent fractions. They are all proportional to each other. So I now know this is a set of similar polygons. So I know they are similar. And the reason is because they have congruent corresponding angles and proportional corresponding sides. It also asks for the scale factor. My scale factor is the reduced fraction of the sides, which is 3/2. Forgot what?
No, there's a C there.
No, I just added it.
Oh, okay.
Okay, similar because congruent angles, or angles are congruent and proportional sides. And the scale factor is 3/2. What word? Yeah, that's what I'm doing. Just writing the bracket, so I have to write the word. All right. Let's keep on plugging here. Sorry, still copying. Yeah, there's 15 examples. We've done 8 of them, which means we're at more than halfway done with our examples.
So that means the ratio to completed examples and not completed, or total examples is 8 to 15.
Yes, ratio of completed examples to total examples is 8 to 15. Ratio of completed to incomplete is 8 to 7. Wow, we're making fractions where we don't have to, or ratios where we don't have to. What?
We have the 53.33 repeating percent of the.
Approximately 53%. Yay. Okay. How about we just get on with it so we can be done?
Yeah.
All right. So Charles is designing a new menu for the restaurant. Determine whether the new menu is similar to the original menu. And here we're talking about geometrically similar, not just it looks like it. Now, they're rectangles, so yeah, all the angles are equal. I'm going to focus on the sides here and the proportionality of the sides. You know what? Since this guy's not helping, I'm going to go ahead and get rid of him and expand this out. Okay, so which side is going to correspond to my 10-inch side? FG. All right. So my ratio is 10 over 12, which reduces to 5 over 6. Now let's do the 12 and the 14. Now, since I put the 10 on top, which is from the left-hand menu, I got to put the 12 on top as well. I didn't focus on the last example, but whichever shape is on top must stay on top the entire time. Okay, so 12 divided by 14 reduces to 6 over 7. Uh-oh, are those the same ratios?
No.
Therefore, they are
Not similar.
not similar because of non-proportional sides. Yeah, it's a non-common scale factor. You could also say that. But there is no scale factor, so we don't have to write it. Okay, same question, different numbers. You want to take a wild guess what the answer to this one's going to be?
Yes. No, it's gonna be no.
All right, let's do the same thing. 10 over 8 reduces to 5 over 4. Then 12 and 9.6 yeah, this is where it's actually beneficial to have the calculator up. But that one, if you do in the calculator, does reduce to 5 over 4. I got to pull my calculator back up to show you.
Now I know your face.
Oh no. Face reveal on accident. Y'all owe me.
You're supposed to do that with 100,000 subscribers. So like in some kind of corresponding one.
Wait, didn't you say like on one of your comment things that you would like do a face reveal of this channel?
Wait, did
I don't know.
The wall? Like, why don't you make that a big wall? Paint that.
I don't know. I got too many ideas to actually do. Okay, let's. $12 divided by 9.6 math enter reduces to 5/4. So yeah. Okay. Oh, so they are proportional. We got equal angles because they're all right angles. We got same scale factor. So yes, write the similarity statement. So that means A, B, C, D is similar to R, S, T, U. Be careful with order there. And the scale factor is 5 over 4. Oh, this one's fun. I know y'all like it whenever I say that. Okay. So, determine if they are similar. Let's start with angles. First off, we got two triangles. The small one, PQR, and the big one, PST. So let's see. What's angle P congruent to? How do you know that?
Because it's itself. It's reflexive.
Reflexive property. Something is always congruent to itself. All right, now let's take angle PQR. What is that congruent to?
Angle PST.
Yeah, you could say angle PST, or you could be lazy and say angle S. No, angle S. Why am I allowed to do that?
Because it doesn't share another angle.
Yep, there's only one angle at that vertex. We got angle PRQ, which is going to go to angle T. All right, now let's do our sides. 11 and 22 reduces to 1 over 2. Now the problem comes in of how do I show that with the other sides? And instead of making a flounder for it, I'll just go ahead and give it to you since we're trying to make this video not 3 hours long. Let's just throw in an X here for PQ. If PQ is X, what is PS? I'm sorry, QS? Also X. Therefore, PQ is X over PS is how long? From P to S is 2X, which reduces to 1/2. You do the same thing over here with your Y's, which is going to be Y over 2Y reduces to 1/2. Hey, they're all the same. What does that mean?
They're similar.
Yes, we got similar figures. So, triangle PQR is similar to triangle PST with a scale factor of 1/2. Yay. 4 more. Getting closer. 1/2. Okay, this one tells you that they are similar. Find x and y. First thing I want to do is find the scale factor. Okay, do you see any set of corresponding sides where I know both numbers? SR and MN. So 32 over 16 reduces to 2 over 1. Now, with my x's, okay, notice here that the 32 is from the left-hand triangle. That goes on top. You must maintain that all the way through. Once you determine whichever one's on top, that one stays there the whole way through. So the left-hand triangle will always be the numerator. So now let's do x. First off, take your scale factor. 2 over 1 equals, now make a ratio out of the remaining sides. X over 13. Cross multiplies to x equals 26. Now let's do the 38 and the y. Scale factor 2 over 1 equals, what goes on top now?
Y.
38 over y. Cross multiply 2y equals 38. Divide by 2 tells you y equals 19. Were you supposed to what? Okay. Okay, these two are similar. Find x. Do I see any corresponding sides that are proportional?
Yes.
Or where I know both numbers?
Yes.
Which one?
S and JH.
S, B, and JH. So I've got 2 over 3 equals, what's going to go in the numerator of the second fraction? Well, I'm going to use BP and HT. Which one goes in the numerator?
Oh, yes.
BP. So x plus 3 over. Now, the scale factor 2/3 does not reduce, so we're good on that. Now, cross multiply, and this is where I told you all at the beginning, I'm just going to go straight to the distribution step. First, 2 times 2x plus 2 is 4x plus 4 equals 3x plus 9. I distributed those as I went. Now, let's solve this. I'm going to subtract 3x on both sides. 4x minus 3x is x. 3x minus 3x goes away. Subtract 4 on both sides, and I get x equals 5. Yes, sir?
I'm dumb.
You're not dumb. You're not dumb.
I wrote down the wrong thing.
You made a mistake. Okay. Questions on that one? All right, Theorem 7.1, perimeters of similar polygons. So, this first thing right here is the same thing you've already seen. It's an extended ratio, extended proportion we did on the very first section. Now, all we're doing is we're saying that the perimeters of similar polygons are also proportional to the sides. So we can just throw the perimeter on there. That's what this example is over here. Let me show you how that works. First off, can I make a scale factor out of these two polygons? What's my scale factor going to be? 12 over 8. So it's important that our right-hand one went first. What does that reduce to?
3 over 2.
3 over 2. Now, What about the perimeter of the left-hand triangle? Yeah, 8 plus 12 plus 10 is 30. Now, the perimeter of the right-hand triangle is what I'm looking for. So, when I set up this proportion, I got 3 over 2 equals... Now, since I put the 12 on top, that means the perimeter from the right-hand one will go on top, which is just a P. The perimeter from the left-hand one, 30, will go on bottom. And now I just cross multiply and solve. 2 times P is 2P. 3 times 30 is 90. Divided by 2, P is 45. Hey guys, good news. Our ratio of completed examples to incomplete examples is 14 to 1.
I like that ratio.
Yay. You know what ratio I like even better? 15 to 0. Which I said we can't do. 0 to 15. Whatever. Okay.
We can have it be 14 to 0 to scratch out.
Or you can do 3.5 to 0.
All right, so first off, we're talking here about triangles DEF, which I'm highlighting in orange here, or tracing in orange. CBF, I'm going to trace in green. Now, I'm going to fill in the information it gives me. Perimeter of CBF is 27. DF is 6. And FC is 8. When you're doing problems like this, go ahead and make sure that they are actually corresponding sides. Like, for example, DF is position 1 and 3. CF is position 1 and 3. So, yes, those two correspond. What do we want to do? 6 over 8 or 8 over 6? 6 over 8?
6 over 8.
Okay, so 8's going to go on bottom, 6 goes on top. So then, which one is going to... Oh, sorry, I'm looking for my perimeter of DEF. What's going to go on top? P or 27?
P.
P, because I am looking for the perimeter of my left-hand triangle. And then my 27 goes on bottom. Left over right equals left over right. Now, I'm going to go ahead and reduce this. That's going to be 3 over 4. So when I cross multiply that, I get 4P is equal to 81. Divide 81 by 4, and you're going to get 20.25. All right, that's our last example. That's it for our lesson. YouTube people, I'm going to go ahead and sign off. So, as always, this is Math Patriot saying, stay patriotic.
Subscribe and like.